Okay, guys, we're starting. All right, so this topic has a lot of formulas that you will want to make sure are on your study sheet. To do the first question, we're converting units, and you will need the diagram: millimeters, centimeters, meters, kilometers. Anytime you're converting units, make sure you've got the arrows on there. So millimeters to centimeters, you divide by 10. Centimeters to meters is 100, and then 1,000 to go from meters to kilometers, and timesing if you're going in the opposite direction. Okay, so for my first question, if I'm going from centimeters to meters, you start at the centimeters here and follow the arrow to meters, which means you want to divide by 100. So I would write my little instruction up here, divide by 100, but you don't get marks for that, but that's just telling you what you do, divide by 100. And then you can either do that in your head or you can type in your calculator. 27.5 divide 100 is 0.275, and it's now in meters. Okay, so there's another one there that you can do. It will involve 2 jumps because you're going from meters all the way down to millimeters. It'll be times 100 times 10. But let's go on to the next one, question 2. Also be really careful that you read the questions. You don't want to mix up area and perimeter. Okay, so these ones are perimeters, which means we are adding up all the sides around the outside of that shape. We need to make sure that we know all of them, though, that we don't have any missing ones. So the lines here, that 8 centimeters, and the lines here, that will mean that this side here is 8 as well. So let's write that there, 8. And I'm missing across here and across there. So to find this one, I would add these horizontal parts, the 8 and the 4, which makes 12. And then vertically, you use the 8 and the 2, which makes 10 for this vertical side over here. So make sure you have nothing missing, and once you've got them all, we're going to write P for perimeter equals, and we just go around the shape and add up all the sides. 12 plus 2 plus 8 plus 8 plus 4 plus 10. And then add them all up. Um, 4 plus 10. It's hard to see when they're all underneath at 44. That will be in centimeters. Okay, all right. Question 3 is a perimeter question, but it's going backwards. We know that the perimeter is 18, that's written underneath there. Perimeter is 18, and we want to find one of the missing sides of the rectangle. So the 3 would be 3 on that side as well, so both sides are 3. And the x on the top means that this one down here would be x down the bottom as well. So if we make this into an equation, we'll be able to solve it to find out what the x is. So there's a long and a short way to write this. If I do it each of the 4 sides individually, I would write x plus 3 plus x plus 3 equals 18. But you could shorten that if you like and just add together straight away. The x plus x makes 2x, and then 3 plus 3 makes 6 equals 18. So that one there is the one I'd really be looking for. And then you want to solve it. How do I solve the equation? Doing opposites. Minus the 6, good. So that's minus 6 under here, which gives 2x equals 12. And what's my second step? Yeah, so they don't always leave you enough room in these worksheets. This is a bit squishy. 12 divided by 2 is 6, so x will equal 6 kilometers because it's the length of that side. Okay? All right, question 4. Looks like we've done these kind of questions already, but it is slightly different. It is centimeters squared to millimeters squared. This diagram that I had up here, if I want to put squareds on all of these, millimeters, meters, kilometers, all those, that means you have to put squareds on all of those numbers around there. So to go from, what was my question? Where'd it go? Centimeters squared to millimeters squared. So here's centimeters squared to millimeters squared. I have to times by 10 squared. Okay, so let's write that next to it. So we'll go times 10 squared, which is also 100. So that is the same thing if you prefer that. And 9.2 times 10 squared is 920 millimeters squared. And guess what happens if they're cubes? It means on all that diagram, if you're doing centimeters cubed and meters cubed, then you have to put cubes all around those numbers as well. Okay, moving on. Now we are doing area. So we have a whole bunch of formulas. You have to identify the shape first, and then hopefully on your formula sheet, you'll have a whole bunch of formulas to choose from. The first shape is a rectangle. Does anyone remember the formula for a rectangle? A equals, yeah, good. So A equals BH. Usually I ask for 3 lines for these kind of questions. I want to see the formula, substitution, answer. So the second line, I sub in that the base and the height is the 6 and the 13. So I do my equal sign lined up underneath, and I go 6 times 13. And then the third line is where we calculate it. 6 13s are 78. Because this is area, it will be centimeters with a little squared on it. Okay. Doesn't waste any time, and I suddenly get to this kind of shape, which is called a compound shape because I'm putting 2 shapes together. What 2 shapes do I have there? The one at a triangle and a square. Good. Now, if you have 2 shapes that have been put next to each other, you're going to add the 2 areas together. But if you have one shape cut out of another one, then you need to subtract the areas. So that's what I'm going to do for this one. I'm going to subtract them. Now, there is a longer way of working out that you might remember from year 7 that we make you do in year 7. I did show you a shorter way this year, so I'm going to do that here. But there is another way if you do need that later on, I can show you. So I'm going to combine my 2 formulas. My area is the square. What's the formula for a square? L squared, S squared, something squared. I don't mind what letter you use. All right, I'll use L squared. I think that was the one we had on our formula sheet. Okay. And then because I'm cutting out the triangle, I'm going to subtract. What is the formula for a triangle? Not BH, half BH. Good. Okay, so there's my first line. Second line, sub in. What is the length of my square, the L? 12. Good, so 12 squared minus. Now I'm doing the triangle and I want the base and the height. Now, I know that 7 is a little bit misleading. The 7 would be that red height there because this is a square, so that across there would have to be 12, right? Probably isn't positioned very well, but it's a square. So the base would have to be 12 and the height would have to be that 7. Okay? And then you type it all in your calculator. So 12 squared minus half times 12 times 7 is 102. Yeah, I put in 0.5 because it's much faster than typing in the 1/2 for the fraction. Millimeters squared because it is an area. F. Does anyone know what that shape is? Not a trapezium. Rhombus yeah, it's the same formula for a kite anyway. It's not technically a kite. Kite usually has 2 shorter ones at the top and then longer ones down the bottom, where the rhombus has all 4 sides are the same, but it's not a square, it's pushed over, okay? But it doesn't matter because a kite and a rhombus have exact same formula. Do you know what the formula for the kite or the rhombus is? Oh, no. No. A, yes, it definitely starts with an A. It does have an X and a Y in it. Does that ring any bells? Half XY. Now the X and the Y, instead, the reason we're not using like bases and heights is because X and Y represents the diagonals of the shape, which is what you have here. So one is diagonal going across here, and 1.8 would be from that corner to that corner. Okay, so it is just half times 1 times 1.8. Okay, type it in. Half times 1 times 1.8 is 0.9 kilometers squared. Make sure you know your shapes so that you can choose the right formulas. All right. Maybe we should just name a few others. What is this shape called? Parallelogram. What's its formula? A equals BH. It's the same as the rectangle. Very good. Next page, what's G? It's a kite, which has the same formula as the rhombus, so it's half XY. What is H? Trapezium. Yes. What's its formula? H over 2 bracket A plus B. The A and the B are the two parallel sides. This is why your formula sheet is so important. You don't have to memorize it this time. I made you memorize it. You can have one page with whatever you want handwritten on it. Yep, one piece of paper. Well, yes, that's, yeah. All right, let's get going. Slaps? No. No. Sorry. Okay, question 6. We are moving into surface area. Okay, so don't confuse surface area with volume. They're the ones that look alike if you're just looking at the shapes. Okay, the first one I've highlighted there is a cube. Oh, who remembers the cube formula for surface area? SA equals, yes. There is an L squared in it, but there's something else. That's for volume. How many faces does a cube have? 6. So it is 6 L squareds because it's 6 squares that go around that shape. So the side length is a 3. It is 6 times 3 squared, and 6 times 9 is 54 centimeters squared. It's still an area, so it's still a squared. So question A has a formula. B is a rectangular prism. It has a formula as well. Do I need to write that down? Yeah. B. LBH is the volume. But surface area, there is 3 different sized rectangles. And there's 2 of each one. So it's 2 bracket LB plus LH plus BH. The 3 different rectangles. Do you remember? Yeah, that's it. But the reason I've highlighted C as well is because C doesn't, we don't have an official formula for a triangular prism. You can kind of make, we are going to make one, but you do need to be able to adjust a little bit. For common sense. Well, you start with a square. You start with a square and, you count up the areas and you soon realize that you're timing that by that. It works. A triangle is half a square. A parallelogram works by pushing it over. They're all related. Because the LB might represent that rectangle on the front. There's also another one on the back. The LH might be this one on this side, and 2 of them the one on the other side. And the BH is the top and the bottom. It is the 3 different rectangles. Anyway, you don't have to worry about that. You don't have to worry about that. You just got to be able to use it. Okay, question C. Sorry? Yes. All right, so for C, For surface area, we are going to start with the triangles. There are two triangles. The formula for a triangle is half base times height. But because there's two of them, I'm going to put that in brackets and times it by 2. I've got two triangles. Now, if you're lucky, you might get an equilateral triangle, which would mean all your rectangles would be the same size. Unfortunately, we don't have that. Each of those rectangles are different. They all have 12 as the length going backwards, but this one's 8, this one's 6, and that one is 10. 3 different rectangles. So we only have one formula for a rectangle, which is base times height, but I need 3 of them because there are 3 different rectangles that I'm putting there. Okay? So let's sub into that formula. The triangle, what is the base and the height of the triangle? Look for the right angle. 8 and 6. Okay, now let's go around our rectangles. I'm going to start with the bottom one, right on the bottom of the shape. It would be 8 times 12 plus, then I'm going to do the rectangle that's on the side wall there, which is 6 times 12. And then finally, I'm going to do the slopy rectangle, which is 10 times 12. It's a big, long line of working, but we're still going to get our answer in 3 lines. So someone going to type that in for me, or do I have to do it? Oh. $264. Oh no, I've missed a rectangle. That's not right. I've missed one. No. Thank you. All right. 336. 336. I was trying to be sneaky. 6 times 8 is the triangles. But I missed my last rectangle. That's all right. Okay. Thank you for fixing that. Okay. Next part. Oh, 336. Yep. Meters squared. All right. Question chapter 3, worksheet B. We're moving into circles. We are doing circumference and, boys, calm. We are doing circumference and area. They are 2 different formulas. Don't mix them up. So in A, what is the formula for the circumference? I have got the radius. The 7 is a radius. So there's 2 formulas for circumference. I want the one with the radius. What is it? 2 pi r. Good. Now, this question has an extra little twist to it. Instead of using the pi button on your calculator, it is asking you to use pi is equal to 22 over 7. So when you sub in on the second line, we have the 2. The pi is being replaced by the 22 over 7, and the radius is the 7 from the circle. Okay, so times that together, and I think you get 44 centimeters. Now let's use the same circle because the 7 here and the 7 there cancel out. Okay, what is the formula for area of a circle? No. Oh, come on. Pi r squared. All right, the radius is 7, but we're still using this 22 over 7 for the pi. 22 over 7 is the pi, and the radius is 7 squared. So it's 22 times 7 was what that become, is 154 centimeters squared, because that's an area. When you do the second one, for circumference, you can use C equals pi d because you have a diameter this time. But there is only one formula for area, which is pi r squared. So if you have a diameter, when you're doing area here, you're going to have to use the radius is 10 in that second formula. Okay, let's do some more of those. Here it is again, but this time we're going to use our pi button on our calculator, okay? So using the pi button, the first question that I'm doing, it's a diameter. So I'm going to use C equals pi d. Pi button on my calculator times the diameter, which is 6, will be about 18 point something. 18.8, we want 2 decimal places, 18.85 millimeters. Then we're doing area again, so A equals pi r squared. My radius, I have to have a radius. What's the radius? 3. So it's pi times 3 squared, which is something. Oh, not that button. 28.27 millimeters squared. Okay? So that's circumference and area of circles. But what if it's not a whole circle? Yes, okay, we keep building. Question 3. We are doing perimeter for step 1 and then area. We've got to do both, perimeter and area for these shapes. When you are doing perimeter, you need all the sides added together. There is a formula to work out the curved part of a sector, we call those. Giselle, do I ask if anyone knows that one? Oh, okay. So I'm going to say P for perimeter equals, you could just do half. Should we do half? All right, okay, all right. So there's two options here. The arc length of any sector is theta over 360 times by 2 pi r. That you need that formula. If I gave you like a 30-degree angle, you would have to use that kind of formula. However, Max has just pointed out, for this question, because it is half of a circle, I could just do half of my pi d formula. Because my circumference formula is pi d, so if I half pi d, that will tell me the curved part. Is that the whole perimeter? No, I still have to add on my straight side, which is 15. So it would be half of pi times 15 plus 15, and that will give me something. Yeah, 0.5 is half. I'm just faster to type it in. So it's 38.56 centimeters. Let's do area now. The area of a whole circle is pi r squared. Do I have a whole circle though? No, I have half. So let's put a half in front of it. Half of a circle. What's the radius of my circle? Yes. The 15's a diameter. So it's half pi times 7.5 squared. Half times pi times 7.5 squared. 88.36 centimeters squared. Okay. Oh, here they are. Here are the ones that I can't. I have to use that formula. The other one was for perimeter though. This one says area. Area still has the theta over 360. You always, that fraction at the front is working out what fraction of the circle am I finding the area of. And then you just times it by your area formula, which is pi r squared. Boys, stop chatting. The theta is your angle, so it's just the 60 degrees. So 60 over 360 times pi times the radius, which is 20, squared. Yep. Don't forget the pi. Times pi times 20 squared. 209.44. Please be careful with your rounding. It's horrible if you're losing lots of half marks because you're not rounding things correctly. Yeah, you've gone all this time without a pen? All right, it's a big section. Let's keep going. We're back to composite shapes again, involving circles this time. So for first shape, I have a little square. It's like we've taken the circle, we've cut out a quarter of the circle, we put a square in there. Because we can. Okay, so we have a square. What's the formula for the area of a square? S squared or L squared, yes. And I have not a whole circle. How much circle do I have? 3/4 of pi r squared. Okay, so you're saying what shapes do I have? Let's add those formulas together. Then we sub in. The length of my square is 5, so it's 5 squared. Plus, do I have to write that 0? Yes, I do. The question says 2 decimal places. If you don't write that 0, you've only given me 1. I won't be deducting marks on every question for rounding, but there will be some, so it will depend on if that's a question I'm taking marks for. Yes, there will be some questions you'll lose marks for not rounding properly. All right, we still have more. Now we're going into volume. It's a big section. This was a very big topic that we did. Yeah. All right. This is not the formula yet, Caleb. We want to go from millimeters cubed to meters cubed. So remember that diagram? We now have to cube everything. All right, Josh or Yoey, what do I do? Divided by 10 cubed. Divide by 100 cubed. Guys, focus. If something is tricky, it just means you need to concentrate more. So 260. Ooh. No, practice what you're doing until you know what you're doing. So that's a tiny number. How many zeros did that have? 1, 2, 3, 4, 5, 6. Shh. So if I'm going from liters to milliliters, I need to times by 1,000. So you can write that above up here. And that is 3800 milliliters. Need a little m in there. Okay, then we have our actual prisms. We want to find the volume, and we also learned how to turn volumes into capacities, which is the second step. So you have volume formulas. The first one is a rectangular prism, and the formula for a rectangular prism's volume is V equals LBH. So that just means the length, the breadth, the height, the three numbers that are on your prism, you times them together. It is 30 times 50 times 20. So that is 30,000 centimeters cubed. To change into a capacity unit, a centimeter cubed is the same as a milliliter. And if you happen to have things in meters cubed, that's the same as a kiloliter. They're the two conversions that I remember, or you might want to have on your study sheet. So as soon as I have centimeters cubed here, on my next line down, I'm going to say that's exactly the same as 30,000 milliliters. But the question says, find the capacity in liters. How do I change milliliters to liters? Divide by 1,000. So that's 30 liters. Okay? Are we nearly done? Nearly. Oh, I thought I'd do the hard one of these. I left the easy one for you. I'm going to do the trapezium. So this is a trapezoidal prism. Or we're going to run out of time. But to find the volume of a prism, any prism, the formula is V is equal to AH. But you have to work out what the area is first, and that entirely depends on what shape you have on the front of it. And this one's a trapezium. So over on the side, I need to calculate the area. There's my trapezium formula. The height is the 3. The A and the B are the two parallel sides, which is the 4 and the 9. So that's 3 over 2 times bracket 4 plus 9 is 19.5. Once you know the area, then we sub it into our volume formula. V equals A, which is 19.5, times what height should I use? No, it is not the height of the trapezium. It is the height of the prism going away from that trapezium, which is the 6. So even though it's called a height, it's not necessarily a vertical. It is the one that's going away from your area shape. So that's 117 centimeters cubed. And we're almost at the end. The volume of a cylinder is V equals pi r squared h. So I'm going to have to leave that with you, and you will have to try and finish off that section.